Hey, hello, can you hear me?
Hello, good morning.
Good morning. Yeah, Moncherry, am I right? Your name? Are you there? Tabitha, am I right?
Yeah.
Yeah, are you
Hi.
are you in France?
Yes.
Oh, really? Quite late time. 1 a.m. maybe there. Are you okay to attend this training? Okay, it is better to start. Today is the last day for the training for the Nimbus. We're gonna start from the water run and the operation test. Yeah, this is the manual of the installer manual. You can get it from the launcher after logon. Uh, the purpose of the water run is to check if the machine working correctly, and and we need to check some volume to see if the teaching is done correctly based on this table. Usually we're gonna select the one step RP for the water run. We're gonna use the water, except the bits. And right after the remove the lysis, we have to measure the debulk plate, each well. Each well, the volume of each well has to be less 20 microliter. And then do it again after remove the wash buffer 1 and 3. And after distribute means when the master mix is made it and they're gonna distribute it to the strip or the plate, and then we have to measure it, the volume. The transfer sample, it means the sample which is extracted sample. When the machine transfer the sample, they're gonna use the 100 microliter elution buffer, right? Aspirate, and then transfer to this plate or the strip. So when we measure the result of the sample, it has to be 25. Okay. Now we will learn how to do the water run. Turn up the simulation mode and log in. Station. Control Q. Select the RP one step. The sample lab here and the tube or plate. The setting it is based on your customer preference. If your customer use the EP tube 1.5 milliliter and use the use the strip, you just select this one. Okay. Fake the barcode because we're gonna use the water. Fake another barcode. We need to put a water here, 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 here. This position, number 5, we need to insert just empty EP tube. Yeah, results look like this. Blue is negative. The red is positive. This is the Korean. This is edit as English. We need to unselect the binding buffer when we use the water as a binding buffer. Okay. But even if we unselected this binding buffer, we need to put the water in this binding buffer tube. The tube too, because when the machines making making a bits, they're gonna use the binding buffer, even if they are doing the step number 6. Okay. And also, if you wanna save your time during the water run, it is okay to unselect the 29, 31, 24, something like that, 15, 19. But at the very first water run, it is better to check these things because this is a good opportunity to check the function of the HHS, right? And then just run it, right? I have a video. We're gonna see the videos. Yeah, this is the initializing. They are doing initializing. At first, they're gonna check the wash popper 2 is inserted. They're gonna check. This is the PK on the right side. And also check the bit is inserted. And the last time IC checked it, and the run is started. The very first step of the RP11 step is PK dispense. They just dispensed it. The next one is IC. Dispense the IC to each well. Move to the HHS, and the next step is lysis buffer dispense. Normally, when the machines aspirate the lysis, the CLD does not activate it because lysis has easy to be a little for me. It is a sample dispense. Sample 1357 are dispensed it. When the machine aspirate the sample, they're gonna do some mixing stage. One, 3, 5, 7 are dispensed. The sample 2, 4, 6, 8 aspirated and dispensed and mixed with the ICPK lysis sample by this mixing stage. And it is time to bead dispense. Even if the step is bead, the machine aspirate the binding buffer. When I make the video, I use the real real binding buffer. Anyway, the binding buffer dispensed it G12 position, and the machine really aspirate the bits, do some mixing, and mix the bits and the binding buffer at G12. They're gonna do some mixing stage it. Yeah, dispensed it. When this moment, the engineer has to check the color is changed, right? Color change means the bit dispense is done correctly. From the binding buffer, wash 1, 2, 3, and illusion, they're gonna use the CLD when the machine aspirated each liquids from the this TUB 2, 3, 4, 5, 6. And also when this moment or something like when they aspirate IC PK bit sample, you need to check the XY positions are each tip is positioned on the center of the each well. IC PK bit sample or this tube. the color will be changed it because the bits are pulled it by this real magnet. When the time goes on, the color getting changed it. Did you notice? And then it is time to remove the lenses. I have 8 samples at this moment. We need to prepare this step. We need to stop it. We need to make the stop. The timing is in this video. I have 8 samples. So when the tip is aspirated, very last sample, when the tip is reaching which aspirate the last sample is ejected. At this moment, you just select the pause button at the method software. At this moment, when they are ejecting the tip, as soon as machine eject the tip, and the machine stopped it, and put out this debug plate and also magnet. The reason why magnet is also put it away from the pedestal, because when we measure the volume by the handled pipette, the bits has to be stay in the debug plate. So that's why we took out the debug plate, both of debug plate and the magnet. And the measure the 8 samples position, prepare it. If the measured volume is higher than the 20 microliter, it means the teaching has to be done. The bottom of the debug plate, bottom of the magnet is a little bit higher, so we need to make it goes down. Okay, always less than the 20 microliter, and put it back. Click the icon, the play button icon, and they're gonna do this step. The color of the debug plate more clearly. Yeah, the last position of the sample is aspirated. When the tip is being ejected, hold the button, machine will stop it as soon as tip is ejected. And then based on this table, took out both the table plate and the magnet and measured each samples. It has to be less than the 10. When the volume is higher than the 10, we need to get the pipetting heads down. Okay. And put it back. Select the play button. Wash popper 2 dispensed it. Shake. Correct the bits. When the time goes on, the color is getting clear. And removed. At this time, we don't need to measure the volume. This is doing an incubate on the heater, not the shaking, which means the HHS is increasing the temperature. The purpose of this step, evaporate the ethanol. Because wash popper 2 is mixed it with the ethanol. So now the ethanol is evaporated. It took 10 minutes. Incubation is done. Move to the magnet. Wash popper 3 are used it. But at this moment, if you look at closely, dispense it, wash popper 3, and they're gonna just aspirate the wash popper 3. For the wash popper 3, they are not gonna move to the shaker. They just dispensed it and aspirate it right away. Okay, okay, at this time, we need to measure another one. I have 8 samples. In this video, there are 8 samples. When the final position of the sample is dispensed it, aspirated, and the tip is used for that position, or ejected it in this moment, just click the pause button and took it out. Both of the tip well plate and the magnet measured again. It should be less than 10 microliter. If the volume is larger than the 10, using a teaching software, we need to get the pipetting heads down. The final, this is the final rekit for the extraction. they just dispensed it to the debug plate. The volume is 100 microliter. It is better to remember the volume. Another 10-minute 100 Celsius degree incubation. Yeah, that's it. Okay, we can divide it one step into extraction and the PCR setup. The very first phase, extraction, is done. Now they're gonna start the PCR setup. This is the RP1. The very first liquid is the MOM. When you look at closely, the movement, immersed at first and loops up. And then they just start the aspirate. The MOM transfer to the empty EP tube at the number 5 position. The buffer immersed just look like check the surface and then aspirate it. The third one for the RP1 is negative control. They just when the negative control is used, they just aspirate it at first try. The final liquid for the RP1 is enzyme. Immerse a little and move out, and then they just aspirate it. Okay, the difference is the negative control and the others is when the negative control is aspirated, the machine uses the CLO function, and the others, they just use the fixed height, okay? So the teaching for the PCR3 is very important. And the 4 kinds of the liquid are mixed in right now. It's time to distribute it, the master mix, 18 microliter. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 9, 10 for the control position. NC is water. they just aspirate it, close the CLD, and put it in the negative control. The volume 8 microliter. Make the machine stop it, measure the volume. The exact, actually, we have to measure at this moment. Position from 1 to 10, the measured volume has to be 17, 18, or 16. Okay. Sample transfer means extracted DNA is transferred to the plate from the debug plate. The volume has to be 8 microliter. Okay, when I made this video, that machine in my office, the channel number 3, has some problem. But CLB, normally they're gonna try 3 or 4 times. Fortunately, the machine success to aspirate it, so it didn't make an error. This is the final step to measure it. The tips is used for the final samples position are ejected. Select the pose again. As soon as tip is ejected, machine will be stopped it. Took it up the display and measure it from 1 to 8. The measure has to be 25, right? 17 plus 8. And then put it back. Select the plus button. When I made the video, I make the setting for the positive. Positive is distributed from the machine, so you can see this kind of the images. They say place the PCR positive control in the small tube rack. I put it positive control in the number 6 small tube pedestal, and then close over. When your customer use this setting, which means we need to do the teaching PCR 7. PCR 7 is for the positive control. not only PCR 1 and 3, we need to do the teaching for the 7. Okay, one step for RP1 is done. When something wrong, you need to do the teaching and try again the water run until we guarantee that this result. Okay, do you have any questions? Yeah, we're gonna skip the 28. We learn about how to, we already learned how to turn on the UV. But okay, I will show you the location where the UV software is saved. It. Okay, the software is Nimbus Channel UV Scan for the UV. Okay, it has to be saved it in this bin folder. If it doesn't, as English, I cannot find the correct one. Put it back. The UV software is initiated. Okay, we need to install when we install the machine. We need to check the UV software also. Okay, 29. With this link, we can download this kind of the sheet. It is used it. It is not the mandatory when the machine has some problem, like when your customer does not use the NIS, which means when they are put the sample number and the information of the barcode has to be gotten from the barcode leader. For example, when I read the barcode number 1 for the number 1, the cursor has to be moved to the right next position. And the same pattern when I read the barcode with the barcode leader for the number 2, the cursor has to be placed at number 3. But the barcode leader doesn't download this sheet. Read 1, 2, 3, 4, 5, 6, and then try again. But the problem, if the problem doesn't resolve it, read the very lower one, and then read 1, 2, 3, 4, 5, 6, and try again. Okay. Okay, we're gonna learn about the maintenance, which is preventive maintenance. The preventive maintenance is a routine maintenance for the machine uh, to keep the machine running and prevent any unplanned downtime from unexpected failure, machine failure. Normally for the Nimbus, the preventive maintenance is done twice in a year. During that, the engineer has to inspect the cable, lubricate, do the semi-maintenance. This is including replacement stop and O-ring, stop disc and O-ring. And after that, do some adjustment and calibration. If you have a tools of the VFV, run the VFV and check the HHS function. Okay, actually the face-to-face training at this moment, we're gonna disassemble whole thing from the channel head, and remove the deck floor and check whole the thing, check the cable, check the label of the cable, and do the lubricate by yourself. But the online training, we cannot provide a face-to-face training. Face-to-face, we cannot provide a practice session. So we're gonna use the video and other things. Okay, we're gonna see some diagram to understand the Nimbus system. Oh. This is the main, something like main board and the CPU of machine. The power from the power source transfer to this system and module controller. It controls whole thing. For the channel and head, the signal transfer to the X interface board, and the signal transfer to the Y interface PCB. This PCB is located right next to the channel number 1. Anyway, by the flex cable, the signal transferred, and also LED bar board. It is located the gantry. This is slide indicator is the front door the PCB, or it has a LED. Okay, and right next to the system and module control, there is a input and output board. This intended to control the HHS, the liquid butter, and the UV equipment are connected. This input and output board. Number a J3 and J1, there is a two same small PCB, one for the left door, one for the right door. Each door PCB control the solenoid to make the movement, and also the Hall sensor are connected. Hall sensor is a magnet sensor, okay, to check if the door is closed or not. Of course, there is a motor and the encoder. On the right side of the machine, there is a home sensor to detect the X-gantry home position. Y home position is for the channel. The red one is module controller. The blue one is system controller. The yellow one input and output PCB. This is motor. On the right side, we got the power source. The power source has to pass to the fuse it, and the power connected this power supply. The AC was changed to the DC. The DC power transferred to this blue system controller, and also to the input and output. The red and blue, the system and module control connected something like the sandwich. And there is a small 2 PCB for the door. This is X interface board. We cannot see right now, maybe. Here there is a X home sensor. The cable are connected from here to here, and the cable moves up to the Y, from the X to the Y. Old one has a LED board, old version's Nimbus, but the latest version does not have the LED board on the backside of the machine. The new version Nimbus has only one LED board. This is located on the front side. The I/O board. Module controller controls X motor, X home sensor, sends command signal to the I/O board. It has a firmware. The big one system controller controls X motor, X home sensor, to the same with the module control. This is X interface. Main function The main function is communication and the power distribution. Drop the 42 to the 5 for the LED PCB. Y interface controls the channel and pipette head. This is the X interface board. Front view, opposite view. This is Y interface board. The flex cable for each channel are connected in here. This is kind of the corrective maintenance case. The error message is there is no connection to the instrument. Please check, and this is the error code. At the same time, there is another type of the error. So at this moment, I check the IP, but the IP setting is nothing is wrong. And when I when I was told about this kind of the symptom, the customer said, I can smell something. Something is burned, they said. So I prepared some PCB and the fuse, spare fuse. The fuse was okay. And then I checked the power. The power supply is good. So I check something and I figure it out. The system controls are the defective. And I replaced it and I upgrade firmware because this PCB has a firmware. This is the program we call the RunMe. When we run the RunMe program, this software automatically detects the current firmware and upgrade it or downgrade it by itself. The Nimbus has Nimbus has 6 kinds of the firmware. But the Nimbus core includes the system controller. Firmware is located in this board. The DAC runtime installed this system controller. System controller is big one. The module controller is smaller one. DAC means something like X movement. The firmware version is a little bit different according to the Nimbus software. So when we upgrade or downgrade the Hamilton software, we need to check the firmwares. Okay. And also, yeah, okay. If you replace the certain PCB, we always have to check the firmware. Yeah, this is the solenoid. This one, 4 sensor, and the flag and magnet. The flag looks like this. This is the hole for the screw. The color is the black, but the opposite side of this flag, there is a magnet in here. So when the solenoid move it, this magnet facing to the detector, that's facing to the sensor. When the magnet getting closer to this magnet, the machine knows that the door is closed. The whole sensor means magnet sensor. Magnet located in the flag, magnet facing to the whole sensor. I just turn on, but at this time the machine off. Yeah. At this moment, machine is turned on, but this machine does not have any channels and pipette head. We're gonna focus on the deck floor. There are the LED. Sorry. When the machine is working correctly without any error, normally module controller system controller I/O board has only one LED. In the normal state, the LED is blinking with the 1 Hertz frequency. Mm. This is reflected light. The LED is here. Okay. The reason why I introduced this video, when the machine has some problem from the PCB, the LED pattern, LED frequency, not the 1 Hertz. This is old version in this, so opposite side, we can find the LED opposite side, back side of the gantry. Okay, do you have any questions? Okay, we're gonna take a 15-minute break, but I ask you guys answer the survey. You can find the link in this chat. It will take a 5 minute. Please answer the survey. Okay, we will take a 15-minute break.
Okay, thank you.
Yeah. Okay, I'm back. Yeah, we're gonna learn about the lubrication. Okay, to maintain the machine, we have to use two kinds of the material. First one is silicone, and the other one is grease. Yeah, first one is silicone oil, and the other one is grease. On the right side, this is the Hamilton official product. Upper one is oil, the lower one is grease. But actually, I use the products. I got it from the local market. The left one, Loctite, it is used to when we install the new stop disc to the pipette head. At first, open the door, remove the whole pedestal, and before you take up the HHS, remove the power cable, unscrew the two hidden set screws, take it out. There are 1, 2, 3, 4, 8 screws. Remove the 8 screws. And then liquid waste tube also has to be removed. There is a 1 screws, removed it. And then we can see the under the deck. Remove this white one. Okay, we're gonna learn how to lubricate the X-rail. If you look at closely, there is a groove on each side of the rail. First, put some grease, not the oil. Put some grease on the groove of the rail, and move the gantry. When the gantry is moving, the grease has to be sucked into the bowl in the bearing. Okay. On each side, there are 2 bearings, which means the nimbus has 4 bearings for the axle movement. Put some oil in here and the opposite side and moves it until the grease has to be sucked in. Grease is sucked into the ball bearing, and then wipe out the rest of the silicone. Okay. Do the same thing, the opposite rail. And we need to do the lubricate for the pulley. This is the pulley. The machine has 4 pulley. Put some grease on the thumb. Grab the pulley and move the machine. Wipe out the rest of the grease. Do the same thing. 2 X-rail, 4 pulleys, right? This is the lower one is the motor, the upper one is the shaft to deliver the movement to the 2 X-rail. Put some grease on the belt, move it, and install the deck floor. Install the deck. Remove the 4 board. Upper one are shorter than the lower one. each channel has jet rail, the same pattern. This rail also has a groove, put some grease on each side on the groove and move it. Oh, okay, move by hand or move the software. The name is service software. Connect, initialize, select the axis and the y-axis for lubrication, the y belt, a y rail. Okay, and also channel has a jet motor to deliver the movement that created by the jet motor. The channel use the jet belt. It is better to put some oil in the jet belt. The oil makes the machine move more smoothly along the jet axis. Put a little oil on the jet motor. It is very good. Yeah, jet axis. We can control the jet movement, and then wipe out the rest of the grease from the jet rail. Now we're gonna learn about the y-axis lubrication. Same pattern. Rail grease. Put some grease on the jet rail. And there is a black one, it is spindle. For the spindle, we're gonna use the oil, not the grease. Okay. This is channel number 4, Y belt. For the Y belt, put some oil. Turn on service software. Using a service software, go to axis, Y axis, move it to dispense the oil and the grease. Yeah, this is the squeezer motor. Squeezer motor has a small spindle. Spindle put oil. Using a service software, pipette squeezer drive and move it to spread the oil. Dispense motor. Old dispense motor has also, actually dispense motor does not have a spindle. The pipette head has a spindle, this one. To see the spindle inside, we need to use this software by dispense drive. Move up the spindle, put the oil. Spindle has oil. Put a little oil and move it to spread it out. And then wipe out the dirt oil, but do not grab the spindle of the pipette head because it is very easy to broken when we grab the dispense of the pipette head. Just leave the paper closer to the dispense. The oil will be stuck into the paper. Okay, and then close the door. The lubrication is done. When you do the lubrication thoroughly from the 2X rail, 4 pulleys, and some kind of the belt for the X movement, and channel, squeezer motor, dispense motor, it will take about 1 hour. Okay, but the lubrication for the maintenance, the lubrication is very important. Okay. And then we're gonna replace the stop disc and O-ring. We need a spare part, O-ring and stop disc, and rope type, and this special tool.